This presentation is on the data analysis, specifically the descriptive statistics. These three tables are just examples of how you can represent the frequency distributions. When we talk about descriptive statistics, we're referring to how you can characterize the shape, central tendency, and the variability of data. And these tables are specifically frequency distributions, and there are three different ways you can achieve that. The first one has just a hash mark for each number that represents each variable, and there are only 5 different responses to those variables, so it's pretty simple to just list the number of times for each of those responses. When your data is larger and maybe more complicated, you may find it more helpful to group the variables or the responses to the variables, and so then you'll have a grouped frequency distribution, and table A and B here are just examples of that. This is a description of the stem and leaf plot. And the stem and leaf plot is another way that you can look at patterns of distribution of continuous variables. The leaf is the right side and will be your last or rightmost digits in your variable, or in your response to the variable in your data, and the stem is the leftmost or the first digit of the measurement range. So let's look at this example and go through what we're talking about for a stem and leaf plot. These are quiz scores. So if the stem stands for the first variable in the score that ranges from 0 to 100, and the leaf refers to the second digit in the score, this means that one person got a 40 and one person got a 49. And the second row, one person got a 56, one person got a 58, one person got a 59. You can see as it goes down, the largest number of individual scores are in our 70s and 80s. So 73, 75, 76, 78, 80, 85, 87, 88. So this is just another way that you'll sometimes see descriptive data portrayed. The histogram is a really common way to represent descriptive data as well. And you can see here, this would be another description of how many people responded with those certain data to those variables. And this one is a little bit of a negatively skewed representation with just a few more in this lower range. But this is what a histogram looks like. We've also talked in this course about the normal distribution and that bell curve. Other ways that data can be represented, especially when we use this histogram, is with the comparison to that normal distribution. So this is a positively skewed distribution, and as you can see, the tail is a little bit to the right on this particular curve. And a positively skewed distribution is defined as an asymmetric distribution of the data with a disproportionate number of cases with a low value and the tail to the right. A negatively skewed distribution is also an asymmetrical distribution with a disproportionate number of cases with a higher value. So the tail is to the left. Now, the other thing we get in descriptive statistics is measures of central tendency. So the mean, the median, and the mode. So you remember the mean is your average. It's the sum of the set of scores divided by the number of scores. The median is when you divide a rank-ordered observations into two equal parts, the one that's in the middle. And then the mode is the score that occurs most frequently. So if we look at this data, 1, 3, 8, 8, 10, we have 5 scores there that total 30. So the mean is 30 divided by 5, which is 6. And the median is the middle. So that's your 8. And the mode is the only one that occurs twice. So that's also an 8. We also are interested in measures of variability. So the range is the difference between the highest and the lowest values in this distribution. We can also describe the data by percentiles or quartiles. So a percentile is a position in the distribution in 100. So the 50th percentile is the middle. The 75th percentile is 3/4 of the way through. The 10th percentile is 1/10 of the way through. The quartiles are dividing the data into 4 equal parts. So the lower quarter, the second quarter, third quarter, fourth quarter. Variance is the deviation of each score from the mean, and standard deviation is both the central tendency and the variability. Coefficient of variation is the ratio of the standard deviation to the mean as a percentage. So it's used with interval and ratio level data. So the range is, as we said, the difference between the highest and lowest values. Your range can also be described as a percentile, and it might be used to describe the score's position within a distribution. Quartiles also describe the score in a distribution, but in 4 equal parts. Another useful way to graphically depict the data is our box plot. And this particular slide gives you a nice box plot that describes cholesterol distribution by weight class. So the top box plot is for kids with a normal weight, under that the overweight, and below that underweight. And you can see that the very first line, the lower limit line in the box, is the 25th percentile, and the upper limit line of the box is the 75th percentile. The 50th percentile is your line in the middle. And that's true for all the box plots. Now, your whiskers on either end represent the range. They're the upper and lower range, with each of these circles being outliers. So the circles represent data points that are more than 3 standard deviations from the means and are described as outliers. So here's an example of small standard deviation and large standard deviation as we're looking at variance in the data. You can see here these scores are all clustered real closely to the mean. So there's a small standard deviation. These scores are widely spread and go the whole range, and only a couple are clustered near the mean. So that's a large standard deviation. This is the normal bell curve and a normal distribution, and it represents the theoretical probability that the distribution in which the horizontal axis represents all possible values of a variable, and the vertical axis represents the probability that these values will occur. So here you have the mean, 1 standard deviation, 2 to 3, and negative 1, 2, 3. And this gives you the probability of those data falling in those parts of the curve. Another way that descriptive statistics can represent the data are looking at standardized scores. And one of the standardized scores that we use is the z-score. And the z-score shows how many standard deviations a given score is, either above or below the mean distribution, or how different is this individual score from the rest of the data. These, again, are other measures of variability with your bell curve in the middle, that's normal distribution, no skew, and then examples of the negatively skewed and the positively skewed. And you'll see the mean, the median, and the mode occurring in different places in these curves. The sum of squares is another statistic that may be included in the description, and it's a sum of the squared deviation of each of the individual scores around a respective mean. Just another way we can describe the data. So now I'd like you to match the description on the left with the items on the right. Just see how you do with these definitions. So, characterize the shape, central tendency, and variability of the data. Is it A, B, C, D, or E? Measure of central tendency. Which response best describes measures of central tendency? Next one is difference between the highest and lowest values. Which term describes the difference between the highest and lowest values? Next one is expressed in terms of standard deviation, called a z-score. Which term does that refer to? And lastly, represents a perfectly symmetrical distribution. Okay, ready to see how you did? Here's the answers. E, B, D, A, C. Hope you did well.